Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC B1241, indicates an issue within the blower motor circuit of the Honda CRV models from 2017 to 2022. This code is critical as it affects the vehicle's climate control system, leading to potential inability to control the heating or cooling functions effectively. The blower motor is responsible for circulating air throughout the cabin of the vehicle, and if it encounters any malfunctions, it can greatly affect passenger comfort. The blower motor is typically located within the HVAC, heating, ventilation, and air conditioning system, often behind the dashboard, connected with electrical wiring that supplies power and signals. When the DTC appears on the screen DA1 or DTC indicator 59, it suggests that the vehicle's onboard diagnostics have detected a fault. The troubleshooting process involves a series of steps to identify the source of the electrical issue. The DTC B1241 signifies a malfunction within the blower motor circuit that affects the vehicle's climate control system. This circuit includes various components such as the blower motor, control unit, and fuses, which work together to manage airflow in the vehicle's cabin. The blower motor itself is usually located behind the dashboard, close to the HVAC unit. It is powered by electrical signals sent from the climate control unit. When the blower motor operates properly, it draws air through the HVAC system, distributing it through the vents inside the vehicle. If there's an issue detected in this circuit, the system may be unable to supply sufficient airflow, leading to discomfort and a compromised driving experience. There are several potential causes for the DTC B1241, starting with loose wiring. Poor connections within the blower motor circuit can lead to intermittent failures, which may fail to operate the blower motor correctly. A blown fuse is another reason. Specifically, the A31 fuse rated at 40 amperes is crucial for the circuit's functionality. If this fuse is damaged, it will disrupt the electrical flow to the blower motor. Additionally, a faulty blower motor can also trigger this DTC. If the motor itself has reached the end of its functional life, it may not respond to electrical signals, indicating a need for replacement. Each of these issues must be investigated systematically to determine the appropriate repair steps. When DTC B1241 is present, several symptoms may manifest in the vehicle. The most apparent is a completely inoperative blower motor, leading to a lack of airflow from the climate control system. Passengers may experience poor climate control, resulting from either no air conditioning or heating, which can be frustrating during extreme weather conditions. Additionally, the DTC will typically display on the climate control panel as either DA1 for models without display or indicator 59 for those with a display. If these symptoms are observed, it's essential to proceed with diagnostics, as ignoring them could lead to further issues within the vehicle's electrical system or discomfort for the passengers. The first troubleshooting step for DTC B1241 involves using the HDS, which stands for Honda Diagnostic System. Start by clearing the DTC using this tool, allowing the onboard computer to reset any stored fault codes. Next, turn the vehicle to the off lock mode and then back to the on mode to prepare the system for re-evaluation. Following this, conduct a self-diagnostic function using either the HDS or the climate control unit. This test will check for any active DTCs that may reappear after the reset. If DTC B1241 or the corresponding indicators are shown, proceed to the next step in the diagnostic path. If no malfunction codes are detected, this may indicate an intermittent failure, prompting a visual inspection of wiring and connections. In the second troubleshooting step for DTC B1241, first turn the vehicle to the off lock mode to ensure the electrical systems are not active while performing checks. The next task is to check the specific fuse responsible for the blower motor circuit, which is fuse number A31, rated at 40 amps. This fuse is located in the underhood fuse relay box. Inspecting the fuse involves removing it from its slot and visually checking for any signs of damage or a blown filament. If the fuse is intact, you can confidently proceed to the next step. However, if it is blown, replacing it is necessary. If the new fuse blows again, it indicates an underlying issue, such as a short circuit, that requires further attention. The third step involves checking the power circuit of the blower motor. To start, disconnect the blower motor 2P connector to isolate the motor from the circuit. With the vehicle in the on mode, proceed to measure the voltage between specific test points. Test point 1 should be the female terminal number 2 in the blower motor 2P connector, and test point 2 should be connected to the body ground. The objective here is to determine if there is battery voltage present at the motor's connector. If battery voltage is detected, it suggests that the power supply to the motor is intact, allowing observations to continue in the troubleshooting flow. Conversely, if no voltage is detected, this points towards possible issues earlier in the power circuit, requiring more extensive electrical diagnostics. In this fourth troubleshooting step, first ensure to turn off the vehicle again. Reconnect the blower motor 2P connector to re-establish the electrical link. Using a jumper wire, connect terminals A and B. Terminal A being female terminal number 1 in the blower motor connector, and terminal B as body ground. By doing this, you bypass any electronic signals from the climate control unit and directly apply power to the blower motor. With the vehicle in the on mode, observe if the blower motor operates at high speed. If it does, this confirms that the motor is functional and the issue likely lies elsewhere in the circuit. If it fails to operate, the blower motor itself may be damaged and require replacement. Step 5 focuses on checking the GND line's integrity. With the vehicle turned off, begin by disconnecting the jumper wire previously used. Then, disconnect the power transistor 4P connector, isolating further components in the circuit. At this point, you will measure continuity between test points. Test point 1 corresponds to female terminal number 2 in the power transistor 4P connector, while test point 2 relates to the body ground. This is crucial to determine if the GND wire is intact. If there is continuity, then the GND wire is functioning correctly, and you can move to the next step. However, if continuity is absent, it necessitates checking for any breaks or poor connections in the GND wire, leading to further diagnostics. In this sixth step of troubleshooting, the focus is on the BLWM line, which is vital for blower motor operation. Begin by connecting terminals A and B using a jumper wire. Terminal A corresponds to female terminal number 1 in the power transistor connector, and terminal B adheres to female terminal number 2 in the same connector. After confirming the connections, switch the vehicle to on mode. With this setup, check if the blower motor runs at high speed, which would suggest that the BLWM wire is functioning correctly. If the blower does run, it indicates the integrity of the BLWM wire, directing you to the next diagnostic phase. Conversely, if it fails to operate, an open within the BLWM wire is indicated, necessitating repairs. Step 7 involves the BLWV line, which is another integral part of the blower motor's operation. First, turn the vehicle to the off-lock mode before proceeding. Disconnect the jumper wire and then the climate control unit connector B, which consists of 24 pins. Your focus will be checking for continuity between test point 1, representing number 12 on the climate control unit connector B, and test point 2, which connects to body ground. If continuity is present, it confirms that the BLW-V line is intact. Should continuity not be found, this indicates a short to ground within the line, requiring repairs to restore functionality. In the 8th step, continuity for the BLWG line is assessed. To execute this check, keep the vehicle in the off lock mode. The focus is to measure continuity between test point 1, which corresponds to number 11 in the climate control unit connector B, and test point 2 that connects to body ground. Performing this test checks if the BLWG line has an uninterrupted signal path essential for the blower motor operation. If continuity is confirmed, it means the wire is functioning properly. Alternatively, if there is no continuity, it highlights a potential short in the system, requiring immediate attention and rectification. Step 9 investigates the possibility of an open wire within the BLWV line. Your task here involves checking continuity between two designated test points while the vehicle remains in the off-lock mode. Test point 1 is connected to number 12 in the climate control unit connector B, and test point 2 connects to female terminal number 3 in the power transistor 4P connector. When you conduct this continuity check, finding continuity means that the BLWV wire is functioning correctly. However, if no continuity is present, it indicates an open wire scenario, which compromises the operation of the blower motor. Thus, repair is necessary. In the 10th troubleshooting step, the emphasis is placed on the BLWG line. To start, you should verify continuity between two critical test points while the vehicle is in the off-lock mode. The first test point is connected to number 11 in the climate control unit connector B, while the second point connects to female terminal number 4 in the power transistor 4P connector. Establishing a successful continuity connection indicates that the BLWG wire is functioning as intended. If you find no continuity, this represents a fault in the wire that must be addressed promptly to restore a normal operation of the blower motor circuit. Step 11 focuses on assessing the power transistor's functionality, a crucial component in the blower motor circuit. Using the appropriate diagnostic tools, evaluate the power transistor to see if it is operational. If the power transistor is found to be in working order, the climate control unit may need to be replaced, as it could be the source of the malfunction. On the other hand, if the power transistor is defective, proceed to replace it. When replacing the power transistor, it is essential also to check the blower motor for possible damage. If any defects are identified, the blower motor itself may need to be replaced as well to ensure effective operation. In the 12th step, the focus shifts to the front blower motor relay, which aids the operation of the blower motor circuit. Turn the vehicle to the off-lock mode and then remove the front blower motor relay from the underhood fuse or relay box for testing. Assess whether the relay functions correctly. If it does, this confirms that the circuit itself is operational. If it is found to be defective, you must replace the front blower motor relay to restore functionality to the blower motor circuit and ensure proper climate control operation in the vehicle. Step 13 involves measuring the high power line known as +B HTR-MTR. This line is vital in ensuring voltage supply to the blower motor. Begin by switching the vehicle to the off-lock mode, followed by disconnecting the front blower motor relay. Using a voltmeter, measure the voltage across test point 1, corresponding to female terminal number 1 in the relay socket, and test point 2 should be connected to body ground. Confirming that battery voltage is present indicates that the +B HTR-MTR wire is intact and functioning properly. However, if there is no battery voltage, it suggests an open in the wiring that requires comprehensive repairs to restore the functionality of the blower motor circuit. In the 14th troubleshooting step, you are evaluating the IG2 AC line, crucial for power distribution within the climate control system. Start by turning the vehicle to the on mode while keeping the front blower motor relay still disconnected. Measure voltage between test point 1, which connects to female terminal number 3 of the relay socket, and test point 2, linked to body ground. The objective of this measurement is to confirm the presence of battery voltage, which indicates that the IG2 AC wire is functional. If voltage is confirmed, it means this section of the electrical system is operating correctly. However, should you find no voltage, it signifies an interruption requiring immediate repair so that appropriate power can reach the blower motor. The final troubleshooting step focuses on the GND line once again. Begin by switching the vehicle to the lock mode to ensure safety while performing this check. Measure the continuity between test point 1, which corresponds to female terminal number 4 in the front blower motor relay socket, and test point 2 is connected to body ground. Ensuring continuity means that the GND line has a complete circuit and is operational. If continuity is present, this closes the failure checks for the blower motor circuit. If continuity is missing, an open in the GND wire is evident, necessitating repairs to restore proper electrical grounding. If the wire that connects to the GND is intact, check for potential poor ground connections at G351 to diagnose possible faults. After completing all troubleshooting steps for DTC B1241, it's crucial to perform a final verification of repairs. Test the blower motor's operation to ensure it is functioning correctly without any abnormal noises or failures. Also, recheck for any DTCs using the HDS to confirm that the prior B1241 code does not return. If everything operates smoothly, without any issues, and no subsequent codes present, it confirms the effectiveness of the repairs performed. This final verification is instrumental in ensuring that the climate control system is restored to a fully functional state, providing comfort to the passengers once again. To prevent occurrences of DTC B1241 in the future, routine maintenance practices should be implemented. Regularly check the wiring systems for any signs of wear, brittleness, or loose connections that could compromise the blower motor circuit's reliability. Fuses should also be inspected periodically to ensure they are intact and functional. Replacing any that show signs of wear or damage promptly helps maintain circuit integrity. Additionally, keep an eye on the blower motor's operational status. Listen for any unusual noises when running, as these could indicate impending issues that need proactive attention. Establishing a routine maintenance schedule that includes these steps will significantly reduce the risk of electrical malfunctions in the HVAC system. In conclusion, DTC B1241 indicates a serious issue within the blower motor circuit that affects the Honda CRV's climate control system. Understanding the components involved, such as the blower motor, the power transistor, and associated wiring, is critical for effective diagnosis and repair. Systematic troubleshooting steps are essential, often addressing everything from blown fuses to faulty motors. Implementing preventive maintenance can significantly decrease the likelihood of encountering DTC B1241 again by ensuring all components remain in optimal working condition. Keeping the blower motor circuit in good repair ensures that passengers enjoy a comfortable cabin environment throughout their travels. Please like and subscribe to the channel. See you next time.